All right, so here we go. The current in the metal wire is given by the expression, and then you can see the expression also. State what is meant by the symbols A, capital A, and small n. Okay, so we need to be very careful with these ones. This is small n and small n and capital N. They represent different quantities. But for A, this is going to be cross-sectional area, and N, it represents number density of charge carriers. Not the number of charge carriers. N represents the number density of charge carriers or the number density of electrons, because E is basically the charge on the electron. Okay, let's move on to the next one. So here we have a situation where at the region X, where the diameter is d, I can call it, for example, 1d. So the value of d1 is 1, and the value of d2 means the diameter on the other side is 0.5d, because it is d by 2. So we need to sketch the graph of drift speed against the position along the wire. I know one of the value already, that the drift speed at x is Vx. So I can plot one point here. At the position x, the value of drift speed is Vx. Okay, so first point we have plotted already. Once again, how do we know? Because when at the position x, the drift speed is given already, which is Vx. Okay, now the question is, if the diameter is reduced to half, what would happen to the drift speed? Can anyone answer this question? Question is, if the diameter is reduced to half, what happens to the drift speed? And let me make it easier for you. How many times would the drift speed increase if the diameter is reduced to half?
2 times.
We are tempted to say 2 times, but 2 is not the answer. Not 2 times. 4 times, says Muhammad Abdullah. Which one is it? Abdullah Hassan, okay. The drift speed will increase 4 times, gentlemen, because if you take a look at the ratio formula, we have the square in the ratio formula. So if the diameter is reduced to half, actually it was on the other slide, so the drift speed would be increased 4 times. You can use the ratio formula V1 over V2 equals to D2 square over D1 square. So this is how you can find out V1 over V2 equals to D2 square means 0.5 square divided by D1 square, which means D1 square means square of 1. So what is V1? Vx. This one is given already. What is the secondary speed over here? We don't know. So V2 and then square of 0.5 is 0.25. We need to find the value of V2. So V2 equals to Vx divided by 0.25. So how many times of Vx? 1 over 0.25 means 4 times. 1 over 0. If you solve this one on the calculator, 1 over 0.25, that means 4 times. So the drift speed at y will be 4 times than the drift speed at x. Let me give you a shortcut also. So either you can use the drift speed formula, the ratio formula. Ratio formula is itself a shortcut, by the way. There is yet another shortcut. All you need to do is write the previous drift speed on the backside divided by the coefficient of the new diameter, by the square of the coefficient of new diameter. So simply this. So Vx divided by square of 0.5 will be 4 times Vx. So gentlemen, this is your new drift speed. Now the question is, we do have 2 points. Shall we join these 2 points with a straight line? Shall we join with a curve that looks something like this, increasing gradient? Shall we join it with a curve with the decreasing gradient? The answer is, if we plot only 2 points, we would never know. So the right way is that we must find the drift speed at another value as well. So I can find the drift speed exactly in the middle of x and y. And then we can see the trend of the points and we can draw the line accordingly. So far what we know is drift speed at the point x was Vx. The drift speed at the point 5 was 4 times Vx. What would be the drift speed exactly in the middle of the wire? And it would not be 2Vx first of all, because they are not directly or inversely, they are related by a factor of square. So in that case, you cannot simply find the average of Vx and 4Vx, which would be 2Vx. No. They are related by an expression which includes square of a quantity. So the easiest method is, we'll use the same shortcut. The drift speed at x was Vx divided by, for the middle part, divided by the coefficient of diameter of the middle part. Now can anyone tell me what is the diameter exactly in the middle of x and y? Any guess? On the left side it is 1d, 1. On the right side it is 0.5. What should be the diameter exactly in the middle? 0.75 is the right answer. You win Face Fresh Beauty Cream. So here we have 0.75d. So we'll use the shortcut, divided by 0.75 square. Coefficient of diameter in the denominator with the square. So if I write it on the calculator, 1 over 0.75 square. Let me take a look. (1.77). So I can write it at 1.777. So I can write it as 1.8 Vx. So you see it's close to 2, but it's not exactly 2. So the drift speed in the middle is 1.8 Vx. Okay, so let us plot this point. So on this line, it would be plotted at 1.8. So this is 2, 1.9, and this one is 1.8. Now we have plotted 3 points. We can draw a freehand curve. And you see already that the trend of the point seems to be a curve with increasing gradient. So needs to be drawn freehand. It will look something like this.